Hi, I'm Ning.
Hi, I'm Katie.
I'm Somi.
And we are working with Professor Robert Stern at the University of Texas at Dallas.
Today, we want to talk about a way to organize videos to foster students' Earth systems thinking and develop interest of non-majors on geoscience topics. Earth systems thinking reflects an advanced mental model of understanding how Earth works. Advancing the understanding of Earth system is currently a core focus of both standards and outcomes for geoscience teaching and learning, and preparation for the next generation geoscience workforce. System thinking is a term originally used to indicate a holistic approach through which to account for dynamic interdependencies among parts, or in other terms, seeing a whole as the sum of its parts. However, this way of thinking is commonly challenging to undergraduate students. Considering the complexity of Earth system, it is not a surprise that students have difficulties to develop an advanced mental model for Earth systems. One particular challenge is that there's no existing intuitive Earth systems model with enough flexibility in fidelity, scale, and time for learners to use. To help learners, here we propose a new model that aims to foster learners' understanding of Earth systems with a special structure and organize geoscience educational videos under Google Earth-like interactive virtual Earth environment. There are so many good geoscience educational videos, and they are very different from each other regarding contents, depths of the knowledge, levels of the fidelity, perspectives of the geoscience topics. And the current problem is how we can organize these videos together to give the learners a holistic view of the Earth system. The proposed geoscience video library model can give learners or teachers the ability to see and compare both the complex systems and single components. The fundamental unit of the system is observable objects or events. Because observable events such as earthquake or objects such as rocks are more intuitive for and familiar by and relevant to people, because that is what they can directly observe or experience. Videos can tell story about those events or objects and also allow scientists to explain a little bit of the science which is directly related to these events. We name this kind of video the place-based videos because observable events and objects can always link to places, maybe a point or a region. Moreover, there are many videos available online can now be directly related to places. They are now directly about these observable events or objects, and they are more about abstract concepts or high-level knowledge of geoscience. We name these videos non-place-based videos. In this geoscience video library model, we use these non-place-based videos to support the learning of the place-based videos. The basic logic of this model is to start with what people know to a deeper and more abstract knowledge of geoscience, giving the opportunity for students to see the scattered events on Earth holistically, building intuitive connections between videos, which helps the learners easily navigate in the model to find the information they need. This allowing the learners freely choose what to learn, and by increasing the abundance of videos in this model, we can also help learners with different kind of background and previous knowledge. Furthermore, this model also takes advantage of the videos regarding its multimedia nature to control cognitive load of learners. Also, students can have multiple examples for the same topic in the library. For example, the topic of earthquake, various place-based and non-place-based videos made by different scientists and experts with their specific styles and perspectives, and discuss this topic in different time and spatial scales. using multiple representations for explaining the same topic has been proven as a very effective method by psychologists. The virtual environment and high freedom allow teachers to conduct virtual place-based education. The place-based videos attract students' attention and let them feel relevant to the geoscience knowledge. We provide the supportive videos and allow students to master their learning so that students can have confidence to learn and get satisfied with their learning topics. These factors fit in the ARCS motivation model, indicating the usefulness of this library model to motivate student learning. In addition, because there always be new events occurring and new videos be created, this library can be updated on various topics and keep tracking students' temporary interest to geoscience, and this continuous triggering of the temporary interest can be the key for developing students' long-term personal interest in the geoscience topics. Lastly, our team also reviews and carefully filters the videos before we push videos into the library so that teachers and students can efficiently use the videos without the concern of the misinformation.
Applying the video library model, we created our own Google Earth Geoscience video library, or for short, Gekko. Currently, the Gekko contains 103 videos across 10 different disciplines of the geosciences. We created discipline representing and event representing icons for place markers on Google Earth. Each of these place markers contains at least one place-based video and one non-place-based video. Here we give two examples on how to use Gekko to teach earth science in classes. The first example is for teaching geoscience introductory classes at the college level. We use Gekko to demonstrate videos about real geological events covered in the news within the past few years. Students can also view videos about independent geohazard events at separate locations on the Earth. Teachers can also educate students by focusing on one individual event. For example, focusing on the Hunga-Tonga volcano eruption in January 2022, Gekko allows one to easily put this single event into context of the regional system, including past events, their systematic reasons, as well as how this single event impacts the overall Earth system through time. This intuitive visualization can help students correlate events and components together, as well as engage students with real problems, while at the same time allowing them to learn more basic geoscience concept in the format of geoscience records or data.
Gekko is also a really great asset for preparing Texas middle school students for the earth science part of their state standard test STAR. Teachers can easily project some of the past questions to the Google Earth environment and pick relevant videos that they want to show students, either from Gekko or from other sources. There is a large database of videos in Gekko that can be selected to project in this virtual environment to help the students better understand the concepts like plate tectonics, hydrology, nature hazards, and so much more. Information such as the description, viewers' understanding of geoscience, and keywords is available for each video in Gekko. Using the index of disciplines and the search function, teachers can explore the video they would like to put into their own geoscience video library for a specific class or for an assignment. The Google Earth desktop app is sufficient for the making of this geoscience video library model because it uses local machine space to save the information. This, unfortunately, can cause a crash of Gekko, so we are now trying to develop a new online application to better support the model. We invite contributions to Gekko from all geoscientists and would greatly appreciate your help in furthering development of Gekko by reviewing videos or by even utilizing Gekko in your classroom.